Okay, you're probably wondering, like, how does this even relate to what we did on Friday, but it's going to. We're going to do what's called the binomial expansion theorem, or just the binomial theorem. I never know how to spell theorem, so I just write THM. Theorem, right? Theorem? Yeah, it's pretty bad. Okay, here's our objective for today. We're going to take something like x plus y, and we're going to bring this to the nth power, and we're going to expand it. Okay, this is not equal x to the nth plus y to the nth, right? Yeah, that would be nice. Some of you know some shortcuts, like if I asked you to do x plus 3 squared, you could do that pretty quickly, right? You do x squared plus 6x plus 9. You don't even really need to write it out and do the whole foiling thing because you know the shortcut. Well, I'm going to teach you that you can do this with any exponent. Like if we had this x plus 3 to the 4th, to the 5th, there's going to be some ways to do it without having to FOIL the whole thing out. Okay, I have two ways to do that. The first way is called Pascal's triangle. Now, Pascal was a mathematician, French mathematician. His first name was Blaise, B-L-A-I-S-E. He was a Christian man in the 1600s. He did not come up with the Pascal's triangle. He stole it from someone. Not really stole it. Actually, it was first published in the 15th century in Europe, and then they called it Pascal's triangle because he was the one that published it. There's actually other people that may have come up with it. The earliest form is actually in the 10th century when they found it, in ancient India and also in Iran. And then the 13th century, China called it. Does anyone know whose triangle it's called in China? It's called Yang Hui, H-U-I. Yang Hui. There you go, Yang Hui's triangle. But in America, we call it Pascal's triangle. I know, everyone has their own thing. It's pretty cool. All right, well, here's Pascal's triangle, or Yang Hui. Yep, she knows it too. Here we go. You start with a 1 up top, and then you have 1s on either side. And then here's how you generate it. You write a 1 first, and then you take the numbers above it, 1 and 2, or 1 and 1, sorry. You add those up, and you get 2, and then you write a 1 again. And then you have a 1, and you add those numbers up. 1 and 2 make 3. 2 and 1 makes 3. And then a 1 on the end. Do you see what we're doing here? Yep. The next one would be 1. 3 and 1 make 4. 3 plus 3 is 6. 3 and 1 is 4. And then 1. And you can just keep going as far as you want. Let's go to 7. We'll go 1. 5, 10, 10, 5, 1. 1, 6, 15, 20, 15, 6, 1. Let's just do one more. 1, 7, 21, 35, 35, 21, 7, and 1. All right, there are a lot of different properties, a lot of different cool things going on in this triangle. It's very symmetric, though, as you can see, okay? If you notice, these rows go like 1, 2, 3, 4, 5, 6, 7, like that. They really call the first row, row 0. But what do we need this for? Like, what is this going to help us do? So what this does is if you have x plus y, you take that to the 0 power. We should all know that that is just 1, okay? And then if you take x plus y to the 1 power, that's equal to x plus y. And look at the coefficients of x and y. That would be the same as the coefficients of row 1. Okay, we just did this a minute ago, x plus y squared. If you take x plus y and you FOIL that out, you will get x squared plus 2xy plus y squared. Okay, that comes from right here, 1, 2, 1. So this is 1, 2, 1. So these are going to be the coefficients when we FOIL the whole thing out. Let's do, if I were to do x plus y to the 6th power. Okay, here's how you would do x plus y to the 6th power. You're going to start with, you're going to look at the row where 6 is at. Do you see that row? It's right here. okay? And what you're going to do is you're going to have 1 is our leading coefficient. So you have 1, and you don't have to write the 1. 1x to the 6th. Our next coefficient is 6. What happens is the x's, the exponents are going to go down, and the y's are going to go up, okay? So the next one would be x to the 5th, y to the 1, which is y. Then the next coefficient would be 15. X is now to the 4th, and y is squared. And look what they add up to every time. The exponents, they add up to 6. Plus 20, x cubed, y cubed. That's right in the middle. It's when the x's and y's are exactly the same. And then I have plus 15. X is still going down while y is going up. And then 6x y to the 5th. Are you running out of room? And then plus, finally, y to the 6th. Who remembers doing this last year? Yeah? Okay, you Algebra 2 kids, you didn't. So if you don't remember doing it, it's because you didn't do it last year. All right? We skipped this. We just don't have time for it in Algebra 2. But that's what we're going to do today. We're going to do expanding like that. I mean, you can take x plus y and you can FOIL it all the way out if you want to, but let's use this binomial theorem, which is a shortcut, okay? So here we go. We're going to do some examples. Number 1. Let's take 2x plus 3 and raise it to the 4th power. Now let me show you how I do these problems, okay? I know it's to the 4th power, so what I'm going to do is I'm going to go to the 4th row of Pascal's triangle, and I'm going to write down what the 4th row is, okay? The 4th row is 1, 4, and spread this out. 6, 4, 1, okay? So those are going to be the numbers that I need. Then what I'm going to do is I'm going to take 2x, and 2x is like just x, and 3 is like the y when you're doing x plus y to the 4th, okay? So now we're going to take 2x, and 2x is going to be to the 4th power. Then it's going to be to the 3rd power, and then it's going to be squared, and then to the 1st power, and then nothing. Okay, so those are my x's, they're going down. The y's, which is like 3 right there, I kind of like to start at the end and go that way. So what I would do is I would go 3 to the 4th, 3 cubed, 3 squared, 3 to the 1, and then 3 to the 0, which is nothing. And then what I'm going to do is there's a plus in the middle, so I'm going to put pluses in between all of these terms. There's a lot of different colors going on. Okay, now we need to simplify this. So the first one is 1 times 2x to the 4th power. The 2 is to the 4th, and the x is to the 4th. So this is 2 to the 4th is what? 2 times 2, 16? Yeah. 16x to the 4th plus. And you can do this on your calculator if you need to. The next one is 4 times 2 cubed, bless you, times 3. That's wrong. 4 times 2 cubed times 3. What'd you get? 96x cubed plus.
Wait.
Yeah?
How come it's times 3?
Ooh, that's the 3. That's like the, yeah. So that's to the 1 power. So they're all adding up to 4 every time.
Oh, so we're not adding the 3 to it?
No, everything's multiplied in there.
Oh.
Yep. It's all multiplied. All right, and the next term would be 6 times 2 squared times 3 cubed, or 3 squared. So 6 times 4 times 9, 216 x squared, plus 4 times 2 times 3 cubed is 216 again, so 216x, and then plus 3 to the 4th, which is 81. And there it is. That's your final answer. Yes, you love it. You love it. Number 2.
Oh, another question?
Oh, yeah.
And so when you're simplifying it,
Yeah.
and do you multiply the parentheses first, like the coefficient first, 4 times 2, then to the 3rd, or
No. Exponents before multiplication.
Oh.
Yeah. And your calculator will do it for you. They know correct order of operations. So, yeah. But, yeah, always exponents. So you do 2 to the third, which is 8, times 4 times 3 in any order. Okay. Let's do another one. Let's do one that has a minus in the middle. Here we go. Let's do 5x minus 2y, bless you. We'll do an easy one, to the third power. The third power will show up in calculus, and if you know how to do the expansion theorem, it's so much easier to do some things that you have to do. Okay, so first thing you need to do is you need to write out your coefficients for the row 3. So row 3 is 1, 3, 3, 1. Okay, 1, 3, 3, 1. All right, now think of 5x, this whole thing, as your first term. So we're going to have 5x is going to be cubed, and then it's squared, and then it's, sorry, I'm boring you, then it's to the first power. 5x. Okay. What, did I lose you there?
No.
Okay. All right. And then the 2y. Ignore the minus sign. Just think of 2y, okay? 2y, I'm going to start at the end and go 2y to the third, 2y squared, 2y. All right, now here comes where the minus matters. The minus is going to alternate. My first term, which is the first one right here, 1 times 5x cubed, is positive. And then it'll be negative, and then positive, and then negative. Okay? So positive, negative, alternates. And now we got to clean it up. So I have 1 times 5 to the third times x to the third. So that would give me what? 125x cubed. Yes?
Yeah.
Minus 3 times 5 squared times 2. 25 times 2. You probably do that in your head, right? 150. This time x is squared and y is to the first power. Now do the numbers here. 3 times 5 times 4, 60. And x is to the first power, y is squared. And then minus 8y cubed. So good, yes? You love it. All right. Part B. Now, yeah?
Is it always going to alternate minus, plus?
Yeah, so it starts with a plus, like you don't write plus out front,
Oh, okay.
but it always alternates. It's positive, negative, positive, negative.
Okay.
Yep. Now let's say you don't like Pascal and his triangle. Yes.
What if there's a negative in the first?
In the first term, there usually isn't. For some reason, there's just not. But then what I would do is I would take the first term and do the negative with it in all of your, to the fourth, to the third, to whatever. Yeah. Let's say you don't like Pascal or his triangle, and that's all right. You can also use NCR, which is what we did yesterday. Okay? So let's say that you have to do the 8th row or 9th row or something like that. Horrible, right? Okay. What you can do is this. Let's start off with a smaller row, though. Let's do, like, if you had x plus y to the 6th power, okay, and you didn't want to write all your Pascal triangle out, okay? What this does is the leading coefficient would be 6c0. And then x is to the 6th, y is to the 0. This is where it comes from. Plus, the next term would be 6c1. X is to the 5th, y is to the first power. Okay, the next term would then be 6c2. X to the 4th, y to the 2nd. Plus 6c3, x cubed, y cubed. Okay, do you see the pattern? Okay, you're going to have some more. Plus 6c2, x squared, y to, no, sorry, 6c4. Dang it. I was doing so good. 6c4, x squared, y to the 4th. plus 6c5, xy to the 5th, and finally 6c6, which is x to the 0, y to the 6th. Okay, so let's talk about this really quick. How many terms are there? 7, right? There's 7 terms. Okay, this right here is the first term. This is the second term. This is the third term. Let's take a look at what the third term says. Okay? The third term of this is 6c2 x to the 4th y squared. That's the third term. Okay, that's kind of weird, right? Because you would think it would be like there's no 3's in there at all. It's because you start with 0. 0, 1, 2. Now, what else do you notice? This number is the same as that number. Okay? And then these two combined make that one. All right, so you need to notice that. Okay. All right, so let me show you how to do, if you were going to do this on your calculator, you don't want to sit there and do 6c0, enter, 6c whatever, enter, right? Let me show you a nice way to do this. So get your calculator out. You can actually plug that into your calculator right there. So let me show you. Go to your calculator, go to Math, PRB. Oh, wait, sorry, hit 6 first. Math, PRB. And then you're going to use the little brackety symbol. It's not a parenthesis, it's a bracket, bless you, which is second parenthesis. And you're going to do 0, comma 1, comma 2, comma 3, comma 4, comma 5, comma 6, and then close your bracket. And then hit enter, and it'll give you the entire row. 1, 6, 15, 20. You have to arrow. Nice, huh? Do you like that? No? Okay. You go 6, Math, PRB. Go to number 3, NCR. And so there's 6. So I have to start with 0. So hit second parenthesis. That gives you the bracket. And then you're going to do 0, comma 1, comma 2. Comma's right by the parenthesis. Comma 3, comma 4, comma 5, comma 6. And then second parenthesis, close it, and it'll give you the entire row. Yeah?
Does that have anything to do with the 6C5 that you wrote up there?
Yes.
Oh, wait, good.
It's exactly. See, what I just did was I found all of those.
Okay.
So when I do this and I hit enter, it comes out, oh, what's so funny? You get 1, 6, 15, 20, 15, 6, and 1. So those all match, that looks like 61, huh? Those all match those 6C0, 6C1, they all match that up. Or you can use Pascal's triangle too. Yeah? Okay. Okay, one last thing. Number, what are we on, 3, 4? 3. Number 3. Okay. Suppose that we want to find the specific term. Okay? Let's suppose that I have x plus 2y to the 8th power. Now, some of you are probably sitting there wondering, how high is she going to make us go on a test, right? I can't make it go too high. It's just so much work, and why do I do that? But maybe I want to see if you know how to find any term, okay? And I say, okay, find this term. Term that will have a, x to the 3rd, y to the 5th. I want you to, basically, you're finding the coefficient. So if I were to take this and do the whole thing, right? It would be 8c0, x would be to the 8th power, 2y would be to the 0. The next term would be 8c1, x is to the 7th, 2y is to the 1st power, yada, 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 okay? I want to find out what this term is going to be in that whole string of things. That's way down the line, isn't it? You're not going to have to find them all. You can go straight to that one, okay? Here's how you do it. we need to do 8. We know 8c something. 8c something. Now remember, I wanted you to notice that when there's a 1 here, the second term has a 1. Remember that? I kind of pointed that out earlier for this reason right here. This is going to be 8c what? 5. It's always the same as the second number, 8c5. And then my x term will be to the third power. And my y term, which is actually 2y, is going to be to the 5th. Okay? So what I need to do is I need to figure out what 8c5 is. I need to multiply that times 2 to the 5th. And then the rest of it is x cubed y to the 5th. So I need to find out what that is. That's what they're asking me for. So you go to your calculator and you do 8c5. Hit enter. And then times 2 to the 5th. 1792. Okay? And that's the term they're looking for. Right there. All right, let's try it again. Number 4. One year I taught a proof because this section has a little proof that you're supposed to do. And I wrote a note to myself that says, skip did not go over well. So we shall not do that. It doesn't go over well. Okay, so let's take 3x minus 1 to the 9th power. And let's find out what ax to the 5th is. This one's a little trickier because the y term is a number. There's no y there. There's no variable. All right, so I know I need to start with 9c something. This is tricky. 9c what? Not 0. 4. 9c4. Kind of got to work backwards a little bit in this. See, this x is to the 5th. It's going to be that 3x is to the 5th, and negative 1 is to the 4th. Okay, 2 things. These have to add up to 9, and the second number will be the second number here. Okay, so now we got to figure out what all of that is. So in my calculator, I have to do 9c4 times 3 to the 5th times negative 1 to the 4th, and that'll be the coefficient in front of x to the 5th. So I need to do that in the calculator. So we'll go 9 math c4, hit enter, times 3 to the 5th, and then negative 1 to the 4th won't change the sign or anything. And you get 30,618 x to the 5th. That would be that term. Okay? So sometimes I'm not going to ask for all of them. I might ask for one specific term out of the bunch, and you got to find that for me. All right.